Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today's discussion will be about a solid which has been cut by a cutting plane which happens to be parallel to the horizontal plane and perpendicular to the vertical plane. So here you can see that we have got one cutting plane which is parallel to the horizontal plane, and this cutting plane is perpendicular to the vertical plane. And now we can have this particular example in which we can see that there is a solid which has been cut by a cutting plane which is parallel to HP and perpendicular to the vertical plane. And once the solid is cut by this cutting plane, so the upper portion of the solid will be discarded and whatever remainder portion of the solid is available. So here we get the edge view of the cut section in the front view, right? So we'll be getting the edge view of the cut section will be available in the front view. Similarly over here we have a square pyramid, and if it is cut, so in the front view we are going to get the edge view of the cut surface over there, right? So in both the cases the cutting plane happens to be parallel to the horizontal plane and perpendicular to the vertical plane. Now when we look at this cut section from the top, that is, we have this arrow of, you see, observer location or viewer orientation. Now in the top view onto the horizontal plane, whatever shape will be available, this section top view is going to give us the true shape of the cut solid. Similarly over here is a surface, that is the section surface, which happens to be parallel to the horizontal plane or parallel to the base. And when we look at the surface from the top, the true shape of this cut section will be available with us in the top view onto the horizontal plane. So therefore in such cases the true shape is straight away available in the top view, and the sectioned top view which is obtained on the horizontal plane will provide us with the true shape of the cut section. Now let us work out the problem that we are going to discuss today. So here we have a cylinder available with us. There is a circular cylinder over here, and this cylinder is not in the upright position. You see, had the cylinder been in the upright position and it would have been cut by a cutting plane parallel to the horizontal plane, what would have happened? So straight away the projections of this cylinder, that is circle, we would have got the true shape of the cut section. It would have been much easier. But here we have got a special case in which a cylinder axis is inclined with respect to the horizontal plane, and this is the axis of the cylinder. So this axis is inclined to the horizontal plane in such a way that the cylinder is resting on horizontal plane on point of its base over there, right? So cylinder is resting on the ground or the horizontal plane on point of its base. And now after this cylinder has been inclined, then we are going to cut this cylinder with a cutting plane which happens to be parallel to the horizontal plane and perpendicular to the vertical plane. But we cannot draw this cylinder projections while this cylinder is lying in the inclined position. So to begin with, we have to assume that the cylinder is standing upright onto the horizontal plane. Just see, so when the cylinder is standing upright onto the horizontal plane with its base resting on HP, so the top view of this particular cylinder will be a circle. So we are going to draw top view first of all, then the front view of this cylinder will be drawn. And once you draw the front view of this cylinder, now you see the inclination process has to start over there. So then we are going to incline the projections which were obtained in the front view at an angle of 45 degree to the horizontal plane. That is either the axis or the base, both of them, they happen to be inclined with respect to HP at an angle of 45 degree. So once we draw these projections in the front view and then we need to draw the projections of this cylinder in the top view as well, right? So we are going to draw the front view projections as well as the top view projections of the cylinder which has been inclined to the horizontal plane at a certain angle, and then the cutting action will start. That is, the cutting plane passes through a point which is 50 millimeter above the ground or above the base of the cylinder over there. So once this cutting action is completed, then we are going to draw the true shape of the cut section in the section top view. Now another thing which needs to be remembered over here, that since this cylinder has been divided, that is the top face has been divided into 8 equal parts, so over here 8 generators are there. So 8 generators are 1A, 2B, 3C, 4D, 5E, 6F, 7G and 8H. So these are 8 generators which are available over here. Now since this cutting plane is going to cut all the generators, so it is not cutting the top face, it is not cutting the base of the cylinder, so it is passing through all the generators. So what we are going to get? We are going to get 8 points of intersection. So these points of intersections have been labeled through 11, 12, 13, 14, 15, 16, 17, 18. And then front view of these POIs will be drawn, and similarly the top view of these points of intersection will also be drawn. So let us work out the projections from step 1. So let us read out the statement. A right circular cylinder of the base 50 millimeter and axis height 80 millimeter is resting on a point on the base on the horizontal plane, and it has got its axis inclined at an angle of 45 degree to horizontal plane, and the axis happens to be parallel to the vertical plane. So initially we will assume cylinder is standing upright with its base resting onto the ground, and then this inclination will be followed in the step number 2. So the projections of solid principles will be used to draw the projections of the inclined cylinder, that is the front view and the top view will be drawn, and then the cutting action will start. That is a section plane which happens to be parallel to the horizontal plane. It cuts the axis of the cylinder at a distance of 50 millimeter from the base. That is the distance of this base point and this axis cutting point. So this distance happens to be 50 millimeter. So cutting plane which is horizontal in nature will be passing through the axis in such a way that it will be cutting the axis at a point which will be 50 millimeter above the XY reference line or above the horizontal plane, right? So we are required to draw the front and the sectional top view, and we need to remember, since this cutting plane is parallel to HP, so the sectional top view which will be obtained on the horizontal plane in the top view will provide us with the true shape of the cut section. And another thing we know by now, if a cylinder is cut by a cutting plane which is inclined, so here the cutting plane is not inclined but the cylinder is inclined over there, so the inclination or the cutting of this will be done in an inclined manner. So the upright cylinder, if we assume it, this will be cut in an inclined way, right? So even though this particular cutting plane is horizontal but the cylinder is inclined over there, so the true shape of this cut section will be an elliptical portion. So this thing we must remember. So whenever a cylinder is cut by an auxiliary inclined plane, we get the true shape of the section as the ellipse. So here again I repeat, the cutting plane is parallel to HP, but since the cylinder has been inclined, so the net effect is just like an upright cylinder has been cut by an AHP over here. So let us start working out the projections. So as we have discussed that initially we are going to assume that this cylinder will be resting onto the ground and on its base, and it will be standing upright. So the top view of this cylinder will be a circle. So this is the projection of the base or projection of the top face of the cylinder. What is the diameter of the cylinder? This is equal to 50 millimeter. So we have marked this diameter, that is phi, is equal to 50 millimeter. And then we are going to work out the center point and divide this circle into 8 equal parts. So we have divided this into 8 equal parts so that every sector will be of 45 degree angle inclination over there. So that this is 90 degree, you can see, and we have divided it into half. So one sector, each sector is equal to 45 degree. So let us do the numbering. 1, 2, 3, 4, 5, 6, 7, 8. These are the points of the top face, and A, B, C, D, they are the points which are there corresponding to the bottom or the base of this particular cylinder. So A dash, B dash, C dash, D dash, E dash, F dash, G dash, H dash, these are the points which will be available here. And similarly 1 dash, 2 dash, 3 dash, 4 dash, 5 dash points will be available over here. Now let us draw the front view. So once the axis point has been located, now we are going to draw the axis. Please see, this is the axis and we have already marked the axis height. So once we know the axis height, now all the projectors from all these points, they will be taken upwards, and this front view of this cylinder will be obtained. So let us do the marking for each and every point. So just see, A dash is the projector which is through A, and it is going to meet the vertical plane on the XY line. Similarly, if you draw the projector through B and H and till it intersects the vertical plane, so you get the points B dash and H dash onto the XY reference line or on the horizontal plane, since the base is resting on the ground. Similarly, the projector through C and G, you get these two projections in the front view, C dash and G dash. And similarly, D dash and F dash, they are projections corresponding to the points D and F over there on the ground, right? Similarly, E projector, you find it as E dash in the vertical plane on the XY reference line. Similarly, we obtain all the projections for the top face points of this particular cylinder. So if this was A, this will be 1. If this is B, this will be 2. Corresponding to H dash, here you have got 8 dash. Corresponding to C dash, you have got the 3 dash point. Corresponding to G dash, you have got 7 dash. And similarly, you can see these are all vertical generator. So since we have divided the circle into 8 equal parts, so 1A, 2B, 3C, 4D, 5E, 6F, 7G and 8H, they are all the vertical generators of this particular cylinder. So having obtained the front view of this particular cylinder, now I want to incline this such that the axis should be inclined at an angle of 45 degree with respect to the horizontal plane. So if the axis is inclined at an angle of 45 degree, so obviously the base will also be inclined at an angle of 45 degree. So as we have already discussed, we are going to initially draw the inclination of this front view with respect to the base angle. So the base inclination will be 90 degree minus the axis angle. So axis angle is given to us as 45 degree. So the angle of inclination of the base will be 90 degree minus 45 degree, which will be equal to 45 degree. Now let us transfer all these points. So once again, this is point 1, E dash stands for point 1, D dash, F dash stands for point 2, this is point 3, this is point 4 and this is point 5. So all these 5 points will be marked over here, and once you mark all these 5 points onto the baseline, then the vertical projector through all the 5 points, which will be equal to 80 millimeter, will have to be drawn. So this figure will be shifted into the new location in the rectilinear transfer method over there. So using rectilinear coordinates, we have been able to transfer this figure from this position to this position. Again I repeat, this is point 1, point 2, point 3, point 4 and point 5. So corresponding to point 1, E dash will be there. Corresponding to point 2, D dash, F dash will be located. Corresponding to point 3, C dash, G dash and O1 dash will be located. Corresponding to point 4, B dash, H dash will be located. And corresponding to point 5, A dash will be located. So from all these 5 points, draw vertical distance of 80 millimeter and join all the vertical projectors or the generators as they were joined in this particular figure. So this figure has been transferred onto the horizontal plane at an angle of 45 degree, right? So the axis is inclined at an angle of 45 degree with respect to the horizontal plane over there. Now observer is going to look from the top. So since the observer is looking at this solid from the top, you see this face will be totally visible 100%. This upper portion of the semicircle, this will be visible, but this lower portion of the semicircle, this will be overshadowed by the projections of this upper portion of the semicircle. So all the points that is starting from G dash, F dash, E dash, D dash and C dash, they will be drawn dotted, and the projections of the circle, if you obtain, if it is inclined to a plane, onto that plane it will appear to be an ellipse. So here you get one ellipse corresponding to the base. Here we are going to obtain another ellipse corresponding to the top face over there. So these two ellipses, they will be worked out based upon corresponding distances of the points over there. Just see, we are going to work out the corresponding points. So these are the corresponding points of the base. How we have obtained them? Please check. We draw a vertical projector through A dash, bring the vertical projector down, and we draw a horizontal projector from the previous plan projection view, and through A point we draw the horizontal projector. So wherever this vertical projector from A dash, it is going to meet horizontal projector which is coming from A, you get the location of point A. Similarly, you draw vertical projector through B and H. So wherever these 2 points, they meet the horizontal projectors through B and horizontal projector through H, you get these 2 points B and H over here. Similarly, draw vertical projector through C dash, G dash and O1 dash, and then you draw one vertical projector and find out the corresponding point of intersection with C, G and O. So where does C lie? C lies here. Draw the horizontal projector. So this gives you C point. Draw the horizontal projector through O1. So this gives you O1 point, and again draw the horizontal projector through G. So draw the horizontal projector through G, you get the location of the point G. Similarly, you draw the vertical projector through D and F, D dash and F dash. Just see, you draw the vertical projector through D dash and F dash. Now work out the horizontal points of intersection through D and through F point over here. Again, another 2 points they have been located. And finally, draw vertical projector through E dash. Wherever it meets the horizontal projector through point E, that is the plan projection point in the previous view, you get the location of point E over here. Similarly, these points, they have been worked out. You see, this is vertical projector through 1, this is horizontal projector through 1, this is vertical projector through 2 dash and 8 dash. Just see, 2 dash and 8 dash. So this is horizontal projector through 2 and vertical, again horizontal projector through 8. Right, so 2 and 8, they have been located. Similarly, you draw vertical projectors from 3 dash and 7 dash, so and work out the horizontal intersections with 3 and 7. So this is 3 and here lies the point number 7 over here. And then draw vertical projector through 4 dash and 6 dash and draw horizontal projectors through 4 and point 6 over here. Right, so we locate 4 and 6 point. And finally, for the top face last point, draw the vertical projector through 5 dash and draw the horizontal projector through point 5 from the previous plan projection view. So you get the point 5. Now I need to do the joining of all these points. So I must remember one thing, which points will be joined. Please see, 1, 2, 3, 4, 5, 6, 7, 8 will be joined. A, B, C, D, E, F, G, H will be joined, and A1, B2, C3, D4, E5, F6, G7 and H8. All these points, they will be joined in this view. So let me join. First of all, work out 2 ellipses over there. And again, as I have explained, since we are looking from the top, this ellipse, which will be corresponding to the top face, it will be dark. And this ellipse, which I have obtained 8 corresponding to 8 points over here, but the lower portion of this ellipse, you see, of the semicircle is not visible because it has been covered by the projections of this upper portion of the semicircle. So the outer, you see, outer ellipse will be dark and the inner ellipse will be dotted over here. So let me join. Please see, this portion I have drawn with the help of a solid line. I haven't darkened it yet. Why? Because the cutting action has to take place once we draw the or complete the projections of the inclined cylinder. So that's why I have drawn it with light color, but still it is a solid line. Then corresponding to this ellipse, you see I have joined it dark because I already know that this portion is not going to be cut. My cutting plane is going to pass through this portion of the cylinder over there. So that is why I have darkened it. So as I told you, the outer portion of this ellipse will be solid line, that is the object line. You see CBAHG. So please check CBAHG. So this corresponds to the upper semicircle of this cylinder, which is visible to the observer over there, as the observer is going to look at the cylinder from the top. But this portion you check CDEFG. So please check CDEFG. So this corresponds to the lower portion of the semicircle of the cylinder base, which is not going to be visible to the observer because this has been overshadowed by the projections of this upper portion of the semicircle of the cylinder. So this portion has to be drawn dotted, right? So once this is completed, now you see all these lines, they are already joining. You see 1A is already joining, 2B is already joining, 3C it is joining by default, right? So I have joined the boundaries over here. Then 4D is also joining, EF is also joining. These are all artificial generator. 6F is already joining, 7G I have just joined, and then 8H it is already joining. So I have joined, you see, points A, B, C, D, E, F, G, H. I have joined the points 1, 2, 3, 4, 5, 6, 7, 8. So these points, they have given me two ellipses. One ellipse corresponding to the inclined circular portion, that is the top face. Another ellipse corresponding to the inclined circular portion, which corresponds to the base. And then these are all the artificial generators: A1, B2, C3, D4, E5, F6, G7 and H8. Now let us draw the orientation of the cutting plane. Please check, where does my axis lie? My axis lies over here. O dash and O1 dash is my axis point. So please see, O and O1 is my axis. In the front view, O dash and O1 dash is my axis point. Now I am going to measure, you see, 50 millimeter above the base, because this axis will be cut at a point by the cutting plane which happens to be parallel to horizontal plane, and the height of this cutting plane with respect to base happens to be 50 millimeter. So it cuts the axis of the cylinder at a distance of 50 millimeter from the base. So you see, I have drawn a cutting plane. This is my cutting plane over here. And once I draw this cutting plane, so I will assume that, please check, this portion of the cylinder has been cut. Please check, this portion of the cylinder has been cut. So it means automatically this portion will be done away with. This portion is no longer available. So that is why I had drawn it with a light but solid line. So solid means it has to be an object line. I have drawn it light because I knew that there is going to be the effect on this particular semicircle part, that is elliptical part, because of cutting off this top face of the cylinder. Now let us work out the points of intersection. Now I can very well see that I can observe over here that this cutting plane, it is parallel to the horizontal plane and it is perpendicular to the vertical plane, and it does not pass through the bottom surface, that is the base. It does not cut the top face over there, right? It does not cut the top face. It does not cut the base of this particular cylinder. So it is passing through all the generators and it is going to cut all these generators. So this particular cutting plane cuts all the generator, and we very well know whenever a cylinder is cut by a cutting plane which is cutting to it in an inclined way. So here, as I explained to you earlier, even though this cutting plane is parallel to HP, but since the cylinder is inclined, so the net effect is a cylinder being cut by an inclined plane over there. So the true shape of the cut section will be an ellipse. So let us see how do we get this bigger ellipse constructed onto the top view, which will give us or provide us with the true shape of the cut section. So let us first of all work out the points of intersection in the front view. So please check it out over here. I am going to again have the parity. A dash 1 dash will be cut by the cutting plane at a point which will be named 11 dash. 2 dash B dash will be cut by the cutting plane at a point whose name will be 12 dash. 3 dash and you see 3 dash and C dash will be cut by a cutting plane at a point called 13 dash. 4 dash and D dash will be cut by the cutting plane at a point called 14 dash. 5 dash and E dash will be cut by the cutting plane at a point called 15 dash. Similarly, 6 dash and F dash will be cut by the POI whose name will be 16 dash. And 7 dash and G dash will be cut by the cutting plane which will be called, this POI name will be 17 dash. And 8 dash and H dash will be cut by a cutting plane whose name will be 18 dash. So corresponding to all these 1, 2, 3, 4, I have added another 10 over here for the POI point, so that I can locate it easily in the front view and in the top view. So total number of POIs, they are going to be 8 in this particular case. So let us start working out the projections of these 8 points in the front view and in the top view over here. So let us start with the point number 1. So please check this out. Point number 1, that is 11 dash. So this is a point. You see I have marked a point. Check, I have marked a point. This is the point of intersection of the cutting plane with the vertical generator of the cylinder, whose name is 1 dash and A dash. So the name of this point is, please check, 11 dash. Name of this point is 11 dash. So 11 dash is the point at which this cutting plane is going to cut this vertical generator 1 dash A dash. I am going to bring this down. Up to which point I need to bring it down? I will be drawing a vertical projector from 11 dash, and it has to meet my vertical projector, that is the top view projector A1, because its original point 11 dash was lying on the elevation generator 1 dash A dash. So the plan point 11 will be lying on the vertical generator, which is 1A over here in the top view. You see, this is 1, this is A. So this vertical projector which is drawn through point 11 dash, it must meet the vertical edge over here, which is shown to be horizontal over here, 1A. So this point name is 11. Now work out the next 2 points over here. So the next 2 points will be, you see, as I have already told you, 2B and 8H. So these are 2 generators which are coinciding with each other in the front view. So there are 2 points of intersection of the cutting plane onto these 2 generators over here. So now from this particular point of 12 dash and 18 dash, I will be drawing one vertical projector, and this vertical projector must be meeting 2 generators in the top view. Which are those generators? You see, 2 and B and 8 and H. So where does 2 and B lie? You see, 2 and B generator lies over here in the top view. 2B generator lies over here in the top view. So the vertical generator which is emerging from this point, it is going to cut this generator at this point. So this point's name will become 12. Similarly, this vertical generator also intersects my generator 8H, because you see 18 number point, 18 dash, it was the point of intersection of the cutting plane with the generator 8 dash and H dash. So I have brought this point down, and wherever it meets the projector of 8 and H in the plan, I get the point 18 over here. Next 2 points, let's work them out. It is these 2 points. What are these 2 points? 13 dash point lies on the generator 3 dash and C dash. 17 dash point lies on the generator which is 7 and G over here. So this is 7 and G and 3 and C, right? So I'll bring this projector down, this point 13 dash and 17 dash projector down, and now work out the corresponding plan projectors for these generator. So please check 3C. So 3C lies here. So 13 dash was the point of intersection of the cutting plane with the generator. 3 dash and C dash, I am bringing this point down. So wherever it intersects 3C, I get the point over here as 13. So the plan corresponding to the point 13 dash will lie on 3C generator. Similarly, the second point was 17 dash. So it was lying as the point of intersection of the cutting plane with the generator 7 and G. So where does 7 lie? 7 lies here. Where does G lie? G lies here. So this is my plan projector for this vertical generator, which is 7G. So this is the vertical generator. So corresponding to this, the front view is 7G. So wherever the point of intersection of this vertical generator with 7G will be there, I obtain the point 17 over here. Next points of projection, they are 14 and 16. So 14 dash is the point of intersection of cutting plane with the generator 4 dash and D dash. So where does 4 lie? Here. Where does D lie? D lies here. So 4D projector lies here. You see, this is my projector 4D or my generator 4D. So on to 4D, this vertical projector, wherever it intersects, I obtain the point 14. And similarly, the point 16 dash lies on the cutting edge intersecting with the generator 6 dash and F dash. Where does 6 lie? 6 lies here. Where does F lie? F lies here. Now this is my plan for the generator 6F. Please check, this is plan for the generator 6F. And now the vertical projector from 16 dash and 14 dash, it is going to intersect this generator over here. So I obtain the point 16 over here. And finally last point, it is 15 dash. So 15 dash is the point of intersection of the cutting plane with my generator 5 dash and E dash. This is the generator 5 dash and E dash. Where does 5 lie? 5 lies here. Where does E lie? E lies here. So this is my generator 5E whose top view plan has been projected here. And then once I draw the vertical projector from 15 dash onto this generator, that is 5E, I obtain the point 15 over here. So all the 8 points, you see, I have distinguished between the original points and the POI point. So POI points have been labeled as sky blue, you can see, whereas original points, they were labeled as black. And here again you can see all the sky blue points 11, 12, 13, 14, 15, 16, 17, 18, they have all been plotted. And once you have found all the POI points in the plan, I need to do the joining. Just see, because we know that the shape of the points of POI will be an ellipse over there. So we have obtained a freehand ellipse in the top view, which happens to be true shape of the cut section. So this is also the section top view. The ellipse which is going to join 11, 12, 13, 14, 15, 16, 17, 18. This will be the section view. That is, this is the true shape of this cut section which has been obtained over here. So this is the true shape, and once we obtain this true shape, now I need to draw the tangent from here so that the boundary of the solid could be located. So this is the true shape of the cut section, and this is the remaining solid which is left after the cutting has been completed. So just see, this portion is left. So it is this portion which has been shown over here. Okay, so this is the portion which we are able to see in the top view. So we have been able to draw the sectioned front view, right? And we have been able to draw the section top view over here. So section front view was the edge view. So we have gone parallel to this because the plane was parallel to our XY reference plane or the horizontal plane. So that is why the name of this plane will be auxiliary horizontal plane. Okay, because it is parallel to HP. So the projections which are obtained through AHP will be giving us the true shape of the cut section. So this is the section top view, the portion which has been shaded through this ellipse over here, and this is also the true shape of the cut section. And you see, since this portion has been cut, so we are going to show that this portion has been discarded. So this portion we have shown as discarded, that it no longer exists. Otherwise, while you are making it onto the drawing sheet, no need to rub this off. So this will stay. It is only for the illustration purpose, that because otherwise if you rub this off, you will not be able to draw all these projections. So this will stay for all practical purposes while you draw this onto your drawing sheet. So this is all about the discussion regarding the projections of the solid which is inclined to the horizontal plane, and then it is cut by an auxiliary horizontal plane which happens to be parallel to the horizontal plane, and it is perpendicular to the vertical plane. So this is all about the discussion for today. We'll be continuing with few more cases on sections of solid in the next classes. Thank you very much. Thanks a lot.